Okay, so we're going to start our first lesson with an intro to Riemann sums. Now, we have done Riemann sums before, it's just been a while, and we're going to do this as the first part of the lesson because when we go to the second part of the lesson this week, we're going to actually use something different than rectangles. So, we're going to look at the first problem right here. It says x squared minus 8x plus 12. We have an interval. We're going from 1 to 7. We're going to use a left-hand endpoint. We're going to partition it into 8 subintervals of equal length. So first thing I'm going to do is I'm going to graph this. So go to your y equals. Let's graph x squared minus 8x plus 12. And you might have to zoom 6 your graph in case you're plugged in from something else, but this looks somewhat okay. I'm going to zoom 6 it anyway, though. Okay, so we've got a parabola. I'm going to draw a quick picture over here. Looks something like this. And we only want this section from 1 to 7, so I'm going to mark that off. Here's 1. And 7, if you look at your graph, is somewhere over here. Okay, so we're going to split this up into 8 subintervals. So from 1 to 7, that's a distance of 6. If I divide that by 8, that gives me 3/4. So I'm going to split 1 to 7 up into intervals of 3/4. So the next part would be at 1.75. Then we're going to have 2.5, 3.25, then we have 4, 4.75, 5.5, I'm running out of space, 6.25, and then 7. I'm actually going to make a chart here. So I've got 1, 1.75, 2.5, 3.25, 4, 4.75, 5.5, and 6.25. Okay, so I'm actually also going to get the heights at each of these points so that I can get, when I use my rectangle, for example, if I go between 1 and 1.75, a left Riemann sum, I would use the left side, go up until I hit my graph, over and down. So I've got a rectangle using the left side height. So I'm going to need all of the heights of these if I want to find the area. So if I want the height at 1, I'm going to plug 1 in to my function here. So you can use your calculator to do that. 1 squared minus 8 times 1 plus 12 gives me 5. I'm going to do that, so if you want to pause it, you can go ahead and do that and double check your work. I'm going to go ahead and plug those numbers in and write them in as I go. Okay, so I'm almost done. So I've got all of my y values. And now I'm going to go ahead and I'm going to estimate the area. So the first rectangle, the base is a distance between 1 and 1.75, so 0.75. The height from the left side is 5. My next rectangle is also going to have a base of 0.75, and that one goes from 1.75 to 2.5. The left height is 1.0625. So I'm going to keep going. All those bases are 0.75, and I'm going to take the left height every time. Oh, and I forgot my last subinterval of 7 over here, so 7 doesn't really matter, but I'm going to go 0.75 times 1.0625. Okay, so now we're going to go ahead and find all that on our calculator. If you want, you can put a 0.75 out in front and then multiply it and add all of these heights that you have. So overall, that gives me negative 5.4375. So that's estimating the approximate area of this shape. Now, why we got a negative number is because part of this area is below the x-axis. Those are going to be negative areas. Anything above is going to be a positive area. Okay, so we're actually just going to set up number 2. So I'm going to graph this. We have the square root of the absolute value. So you're going to go to the math button, over to number, and there you have the absolute value of x minus 1. And we're going to go from 0 to 5. So I'm going to sketch a graph here. Oops. Looks like this. And we want 0 to 5, so we want this region right in here. So we're going from 0 to 5. This time we're going to use a right-hand endpoint. So we're just going to set this up. We're not going to actually solve it through. But if I split up 0 to 5 into 10 subintervals, that would mean I'm going by increments of 1/2. So if I made a chart here, I would go 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and then 5. And then we're going to find the height at each of those points. So I'm going to plug 0 in to my function. That gives me, and the absolute value fixes so you don't have any negatives underneath. So we've got the absolute value of 1, which is 1. Then we've got the square root of 1/2 minus 1, so negative 1/2. If we take the absolute value of that, we get 1/2. If you square root that, you get the square root of 1/2. Here we're going to get 0. So go ahead and go through and calculate all of those values. We've got this. Okay, so this one's going to give us 1 again. So some of these are repeats because the graph goes down and then back up again. So next we have the square root of 2.5 minus 1, so the square root of 1.5, so the square root of 1.5. I'm just going to write that in. And then over here we have the square root of 2. Over here we have the square root of 3.5 minus 1, so 2.5. The square root of 3, the square root of 3.5, and the square root of 4. Okay, so a right-hand endpoint means that I'm going to take the right height each time. So my base is always going to be 1/2. So if I just do the first rectangle, we got our base is 1/2. The right height would be the square root of 1/2. Plus my next rectangle, the base is 1/2. The right height is 0. The next one, 1/2 times the square root of 1/2, and we're going to keep on going. Until you have our answer. So then at that point you could plug in your value and get the approximate area. So one thing I do want to show you is you can get the actual area. What you're going to do is you have your graph. You go to calculate, so second trace, and you're going to pick the last one, number 7. We're finding an integral. An integral is an area under a curve. And you're going to tell the starting point. So our starting point's at 0. It says lower limit. You're going to type in 0. Press enter. Upper limit, you're going to type in 5. Press enter. It's going to shade that region and then give you the actual area under the curve. Now the Riemann sum is just estimating it. So if you were to actually solve this and plug it in your calculator, you should get something close to that answer, but the actual answer is 5.999, so I guess it rounds to 6. Okay, we can also do a midpoint Riemann sum. So let's go to number 3. So I'm going to graph number 3. We have x squared minus 5x plus 1. So we have a parabola that opens up, and we're finding the area between -2 and 7. So I'm going to sketch a graph of this curve here. -2 and 7's way over here. Okay, so we want 8 subintervals. So if we're going from -2 to 7, that's 9. And I'm going to divide that by 8. That gives us our subintervals. So, and then we need a midpoint. So this one's a little trickier. So for example, and we're just going to talk about this when we're actually not going to actually solve it because it's just something that might show up on a multiple choice question if you're taking a standardized test. But a midpoint Riemann sum, what it does, so I'm going to draw this a little bit better here. So let's say you're doing this first little increment here, -2, and then if I add 9/8 to that, I'm going to get that as a fraction here. So that would be -7/8. So I'm going to make this a little bit bigger. So that first interval, -2 to -7/8. We have a width of 9/8. Now, if we're doing a midpoint, so I'm going to draw this curve a little bit better here. It kind of looks like that. Normally, when we draw our Riemann sum, we would take the left side and go up and over to create a rectangle, or we could do the right side. We'd go up and over to make a rectangle. When you have a midpoint, you're going to take the middle, go up, and that's going to be the top of your rectangle. So let's just practice finding the area of just this one rectangle. Now, I would consider this a pretty challenging problem because we have fractions involved. So if you were to take a test or a quiz, I mean, you won't have any tests so far, but they would give you ones that are pretty easy to split up. So let's just evaluate the area of just this midpoint rectangle. So my base is 9/8. Now my height, I gotta find the height at the midpoint. So first I need to find the middle between -2 and -7/8. So all I would do is just add those up. Right, so on my calculator, I added those up, -2 and -7/8. I'm going to divide that by 2, and I can change it to a fraction, math enter, enter. So the midpoint is -23/16. So if I want the height at that point, I'm going to plug that into my formula. So -23/16 squared minus 5 times -23/16 plus 1. So I'm going to plug that in my calculator next so I can get my height there. Ooh, my height, something crazy. So my height is 2,625 over 256. So that area of just that first little rectangle, now if I multiply that by 9/8, I get 23,625 over 2,048. So now this would take us a while, right? Because we'd have 8 rectangles to do, and all with midpoint Riemann sums. So that's just the first rectangle. Then I would have to do the other 7, add them up to get my estimate. So let's practice finding the actual integral. So let's go to your y equals. You should have that typed in already, but if you don't, go ahead and pause it and type it in. Hit graph, and we're going to calculate something. So you're going to go second trace, number 7, and we're going from -2 as our starting point, press enter, and then 7 as our ending point. It's going to shade that region and then give us the actual answer down at the bottom here. It says 13.5. So I'm going to write that in. Okay, so this is a pretty rare type of question. Most likely you're going to get asked questions about left-hand endpoints and right-hand endpoints, and you might see a midpoint every now and then. I just wanted to show you how you would set it up in case you ever get asked a question about a midpoint formula. But it's more important at this point for Calc 1 that you definitely know how to do a left-hand endpoint and a right-hand endpoint. Okay, so this is the end. If you have any questions, feel free to email me, or you can go back and rewatch. You can replay questions as many times as you want.